I'm here to give you guys an eruption update on Kilauea's summit eruption that began about 20 hours ago within Halemaumau crater. Let me wait while you guys kind of connect and just make sure our streams are going here. And we'll show you guys some of the newest imagery and whatever else we can get from USGS, live monitoring. We have some social media content to share with you guys as well. And so let's see what we can get going here. All right, so it looks like we're on. Let's see if I can try to get the comments up here so I can follow you guys. All right. Just a minute, you guys. Thanks for bearing with me and let you guys join in here while we're getting set up here to do our update 20 hours into the eruption. All right, so it looks like we're on. All right, let's see if I can get that. Checking in. Various streams. Thanks for bearing with me, you guys. I'm just setting up here to give you guys an update. And all right, it looks like we are set on all of our various friends. So I'm just trying to make sure that we can get our information out to as many people as possible here. And so we're kind of just checking. I'm just checking all the streams here and making sure that we can get everything out straight. Okay, so here we are. All good to go. Thanks for bearing with me, guys. So it is Monday, December 20th, 5:30 p.m. Hawaii Standard Time. This eruption began 20 hours ago here in Hawaii. We have a latest image from the USGS here. I will show you guys this image that's been released by USGS from this afternoon, showing what is essentially the fissures. You have one most dominant fissure over here. All right, this may be the third fissure that we saw forming, essentially the third area fissure forming right over here. The first one being right through here. The second one being in here. And this one has died off in this particular photograph. But you can see that both of these, and this one especially, which is much stronger, are feeding an active lava lake, which is circulating within Halemaumau crater, just like this. If you're just joining us now for the first time, the water pond that was in there was quickly evaporated away. We'll show you guys some sequences of how that actually happened and what's been happening since then. I'm glad to report that the USGS website is performing fantastically, and so we can see lots of information from USGS coming through today, right now. So first thing I would like to show you guys is this most recent overflight from the USGS. So I'm going to back it up here and play their intro. So this video is released this afternoon by USGS, and so this is two fissure vents. Here's the one gushing right in here. Second one in here. You can see there's actually a second bubbling spot at the bottom of this. Number 1, number 3, number 2 by this point is actually stopped venting, right? Note down here that this lower part of this fissure 1 complex is actually bubbling, and it's also putting lava down into this pond. So let me let it reloop here for you guys, and I'll point that out, and maybe I can zoom in a little more too. Maybe not. Let's try that. All right, so right. Oh, it's kind of off the screen here. All right, so right in here, the spot right in here. Let's rewind it. Right in here, right? It's kind of on that old piece of land. It's now been buried, and it was cascading into the pond. But now it's essentially reached the same level as the lava in this video. We can come back to this video here shortly, but what I want to show you guys coming up next is I'll just point out this is where this is a more recent view from the live webcam Halemaumau on the USGS website right here. the Kilauea West Cam. Let me zoom in for you guys can see a little better in here. You can see the lava filling in overnight, getting to be daytime. No more water. The water is there at the beginning of this image. This is kind of the image the day that the pond, the water lake, and Halemaumau disappeared. So this is all from the USGS website, so I really appreciate the data streams they're providing. This is one that's off of their thermal camera, looking into Halemaumau from that same kind of area from the west. And so this is hugely interesting, and you can see maybe not so well. Let me kind of scroll it over here. If we get the scale over here on the right, we can now see that we go from 80 to 350 to 600. So now we have a good proper scaling on this image, right? So it kind of had to be corrected. Even still, we have a few of these images that have kind of overexposure. We have black areas or we have white areas, you know, depending on how the sensor was able to integrate everything it was trying to see. You know, there's a lot happening right there in front of that sensor, infrared sensor. So while we have this image on the loop here, I want to point out, you can kind of see that the whole lake level is rising, right? At the end of the sequence, the lava level is up to here, right? And I'll just keep drawing it around, right? Something like that, right? So in this thermal, you can actually see there is a bench right here, right? This old block that was an old piece of Halemaumau crater floor. This is a little wedge right here, and it's being overflowed, right? You can kind of see the lava lake is rising up. It's overflowing over top of this. It's like almost like a little tsunami that comes over right there. Covers this old piece of land, and is also now drowned this vent that was that lower part of that number one right over here. So that means we now have the vent underneath the lava level in the situation, right? So it's actually going to bubble up through the lava. We're going to have a bubbling lava lake, at least from that one location. Of course, the main active, strongest vent is this one over here on the east, on the left of our image right here. By the way, I want to point out that the image right above me up here, that is image by Genes Way National Park Service from Hawaii Volcanoes National Park Facebook page. You guys can go check them out. They're having also some fantastic imagery sharing up there, and so also good information about how to visit the park if you guys are on an island and want to go and see or feel what it's like at the national park at this point in time. You know, that's crucial information we'll cover a little bit later as well. But for now, now that we've had this kind of animation on loop, you know, a couple other things you can see here. There's this crust, right? A solid island crust in the middle. It starts off just rising straight up, and then it kind of starts moving over in this direction, right? You guys can see that right through here, this thing. All right, so let's go back, and I'd like to show you guys this frame by frame. Okay, so we have here the frame by frame of this eruption from the thermal camera. So this is the lake of water before any lava came into it. That was at 9 p.m. This image at 10 p.m. is already showing where the lava came into the lake and is steaming everything away. And if you don't recall, this kind of was part of the first set of videos we did. The USGS released this initial imagery of every 2 minutes of the thermal camera and these vents opening up and boiling away the lake. And a big part of that, early part of that, was all the massive steam that was formed, right? All the massive steam that's going to form right in here, right, off of this lake. There it is, as it boils away in those first 2 hours of the eruption. So we are skipping past that now to only every 1 hour. So we're going to go, this is a 10 p.m., 11 p.m. By this point in time, you guys can see no more water. There's still some steam, right? But we're kind of close to the point in time where we can certainly see that there's all lava covering the bottom of this pit in here, all through there. So there's no space for water to be in there. That's by 11 p.m. Hawaiian time last night. So we'll keep going. 12, 1 a.m., 2. Okay, so now I can really see the image over here. We've jumped up to a 350, so we have a better resolution. We've had enough steam clear. The sensor is having a better job of seeing what's going on in there. However, we do still have these black areas where it's kind of basically saturated, you know, where it's not reading the signal properly, not processing it, or there's some kind of error. But of course, we can see that that's the brightest part where the lava is the hottest. You know, that's essentially what I take out of this particular frame. So moving on, next one. You guys can see the lake is rising. We have this channel that's kind of moving from the south to the west, right? That's kind of a part of the overall circulation of the lake right here. And so this piece of crust is the one that's going to be moving over in this direction as we follow it over. Still rising straight up, straight up, straight up. Okay, now I'm going to rewind because go back a couple frames here. You can see a little bit better of the speed of this, right? So here we are. This is a 6 a.m. image. I'm going to zoom into this. And so on the 6 a.m. image, we still have the second fissure, fissure number 2 over here, was still active on this lower part of the old crater floor that's remaining within Halemaumau, right? So we had this fissure number 2 that was active in here. And let me zoom back out here for you guys. And what I'm going to show you guys is we're going to see the lava start to lap up and onto it. So right in here, the lava starting to lap on and come on to this piece of land, right? This is a big piece of land down here. So lava is going to come up and over. All right, it's going to cover up this area over here that had been a fissure, right? It's also covering up this area right in here. So this fissure, which if I rewind, you can still see it spattering right here, right? Let me get the timestamp for this image here. This one is at 11 a.m. So our 11 a.m. image right here. Oh. Let's zoom out here so we can get our images lined up. All right. So yeah, so 12, you can start to see here, it's starting to get a little bit encroached upon. I see a little bit of spatter still here. Looks like it might be peeking up still through that rising lake of the surface of the lava lake by 1 p.m. By 2 p.m., we have a completely oversaturated image. But by the time we have this image coming in at 3 p.m., we can see that by now it looks like this bubbling is happening within lava all around it. So essentially the lake surface has risen to the height of this vent, completely covered up, except for the small part in here, as of this image, right, of the thermal image. And so let's advance it and see how much further lava keeps coming. Yep, here it comes. Right in here, it's gonna keep lapping on. That's the last image taken from 4 p.m. So it's probably a 5 p.m. image that I haven't had updated here. But we have this lava moving on to the last piece of this bench. And so our most vigorous vent over here, our third fissure that opened, is quite a bit higher than this level still, right? And there's another one kind of up on a wall you can't quite see through here that's a bit weaker, but it's pouring lava down as well. And if I go back to the video now, you can see that here's that main one dropping lava down and in. Here's that weaker one kind of going down. Right here is where the lava is covered up, that whole area of the bench. Right in here is that other weaker spattering area. That's the weaker spattering area that we just highlighted for you guys. That's getting covered and is now bubbling through the lake of lava. So, kind of try to go through this quickly. We'll be able to let you guys rewatch it. We've covered a thermal. So there's quite a lot of Summit webcams now, and the Usgs webcams are responding quite well. So you can see, I'll give this a reload right here, and it'll all reload pretty quickly. So we have from the west part of Kīlauea. This is probably one of the best cameras, Kīlauea West. The east wide angle might be showing some things here on the right side of the camera, right in there. The Halemaumau wide angle is kind of showing an upper view, so you can kind of see the glow coming up and through there, but you really don't see it nearly as well, the lava surface, as you do from the west camera. And of course, if you scroll down, that's where you get the image of the infrared, right? So, and this one over here is just seeing a bunch of steam across. There's not any vent in the field of view of this particular camera. But in any of these, if, for example, you want to see like where I got that thermal image, when you see an image like this off the USGS webcams, you can click on it. And so you'll come to the page that has the static image on top, but you just keep scrolling down. And right below that, you'll have an automatic generated image for the last 24 hours produced by the USGS. And this is fantastic. So you can see right in here, maybe we can see what the last image might show right in there, right? We can really see the lava coming up and over that old piece of crater floor that was remaining of the old bottom of Halemaumau, kind of on the northern part of it, right? That kind of slid in the 2018 collapse, and that one big chunk kind of survived, intact as one big block. And now it's been completely encased and covered, been glazed over by this whole new flow, right? So we know the lava lake has an interesting cross section, right? It's going to be deeper in this area right through here, but it's going to rise up and above and come up this wall as well, just as it kind of fills to the other side as well. So now you guys know how to reach those cameras. I want to kind of just point out this map that was put out earlier today, perhaps last night, and the location of these vents right on the map. So this is a location of the pond as it existed yesterday. The water lake replaced with lava. Right, USGS image. The main most vigorous vent, the third vent, is this one right here. The one that's kind of dying off and getting covered is this one right in here. There actually was a second one. The one we saw covered is probably actually more right in here, but there's a kind of a series of vents right here, a cluster of them, right, an upper and lower one. Likewise, there's upper and lower ones here and here. And this one is still active, coming downhill. And this is the one that's actually bubbling and covered up. So this gives us an idea of the scale of how far the lava is actually covered in here, right? So the lava, if it's covered up this lower vent down in here, okay, that means the lava lake is now approaching this kind of size. Right, it's getting big fast. The lava's pumping down there. I think it's filling fast. It's we've seen reports, and I'll show you guys that SO2 emissions may be comparable to what we saw in 2018. And so we wonder about the flux of lava coming out, how fast it's coming out, and how quickly it's filling. And of course, where that would lead us in the long term. Of course, the most, I suppose, comforting thing about the whole situation is that we got past the first phase of the water boiling away. The lava came in fairly slowly and actually vaporized it rather than creating any major explosions. And so, and we'll see some consequences of that kind of later on. But we've passed that phase now, where it seems like it's a more of an effusive eruption. The lava's coming out through the pathway it's already established. It doesn't need to break anything new open, right? It doesn't need to explode anything else. And so we're kind of at a stable equilibrium of lava gushing out of the ground from Halemaumau. And so, well, this is supposed to remind me, oh yeah, sorry, yeah, we did look at this video. So the USGS has actually been putting out more images. This is actually an animated GIF here, kind of showing the fountain, the most active fountain, that third one, cascading down this wall, right, and plunging, bubbling into the plunge pool down in here. This is a point where we still had a crust forming in the middle. This was at this point, maybe something like 12 hours ago. It might have been something like 11 p.m., so maybe not quite 12 hours ago. Maybe more like 17, 18 hours ago, something like that. And you can kind of see that the lake surface since then is going to come up, as we showed you in infrared. It's probably somewhere farther up now, right? But still, this vent is quite a bit higher than the rising lake still. We can talk about that in a future update, whether that will have any other impact. But let's move on to the gas now, since we are trying to review the signals fairly quickly. We have here the USGS Gas Monitoring page. This is the actual continuous gas measurements, right? This is the ones we've been looking at and looking for a signal and not seeing much. We saw a calibration signal last week on this station here, HR, PKE. But finally today we can see at the HRSDH, presumably Sand Hill, we have a big spike here and an SO2 coming out finally. So the highest value up here is looking at about 50 ppm SO2, right? So that's certainly a big spike, right? And that could be something that if we can integrate the whole amount released over the eruption, we can maybe have a better idea of how much lava is coming out, or the dynamics of lava, how fresh it is, that kind of thing. That's something we'll await eagerly the USGS to inform us with. So here's the other plot, and kind of see here's our signal at this PKE. It may be that it's further upwind, so it may not be as an optimal location to detect the signal. So there, it's only detecting in a range of what we're seeing as 10 ppm on a scale, and this over here being the earlier calibration signal, we presume. Although this level of 60 ppm is similar to what we're seeing 55 ppm here. The actual real signal just came in today, corresponding to the active ongoing eruption within Kilauea. So what are some consequences of this? We do have a lot of air quality stations around the island. So this is by the DOH, air.doh.hawaii.gov is this website. I'll give it a reload here and see what it's going to show us. And so it's showing us its sites in Hilo, Kona, Mountain View, Pahala, Ocean View, Kamehameha Schools, Hawaii, Nalehu, Leilani, all being green, right? So good for all these levels, right? So there's, click on Pahala here. Let's see what we have, more information on Pahala. So on Pahala, you can actually see that we went through some yellow and red phases earlier between the hours of especially 11 a.m. and 8 a.m. down there, right? With red especially at 9 a.m. to 10:30 or so. And that's what this plot right here is showing. I'll zoom this in for you guys. Right, this is the DOH site showing air quality in Pahala, right? So you can see that was green and yellow, 7:45 till 8:45, red 8 till 9:15, back to yellow, drop briefly to a green to yellow, but you can see that air quality is certainly our biggest concern perhaps now as impacted people from disruption on this island now, because Pahala, Ocean View as well. Let's click on Ocean View here and look at the DOH Ocean View site. So Ocean View didn't have quite as much, but it did have a half-hour period, it appears, where the SO2 levels went up to 0.15, right? I can actually go back and just noticing now, I can go back to Pahala here and we can zoom in for you guys. Look at some of these reds. 0.25 ppm, 0.21, almost 0.22 ppm, 0.28 ppm came in at 10 o'clock in Pahala. 0.24, 0.22, 0.21, 0.17, and currently we're down at 0.004. So we've got past that right there. So that is the state of Hawaii gas. And I will pause here and address some questions shortly, but I want to show you guys this information as we have it here, because we also have the National Park gas data, right? So the National Park has this current air quality webpage. And if you scroll down here to the advisory history, you can see that there's been some unhealthy for sensitive groups orange alerts at the park today as well. So if you actually let me zoom in so you guys can see here, there's this little link down here, advisory history by site, on the park page, and if you click on that, it takes you to this, and this gives you two columns. This column on the left is SO2, the column on the right is particulate, things like ash, Pele's hair, actual particles flying through the air, right? And so everything is green, green, green. Visitor center, all green. We scroll down, it's actually down here at the Kahuku cross fence unit. SO2 has been spiking. This is kind of over near Ocean View as well, Pahala Ocean View area. And we can also see in a particulate graph that we do have particulate readings in Pahala, right? And that's something that also was reported to me by Ikaika Marzo earlier today. We said that there has been a report of particulate matter falling in Pahala, maybe not exactly ash, but an ash-like small particles of maybe glass, Pele's hairs, the very light stuff that can kind of stay aloft on these plumes of gas for a long time. So, all right. So what I'm going to do is I'm going to put on this image here and just talk quickly about this before we move on. This is an image from the Mauna Kea Weather Observatory. Weather Center that is in support of the Astronomical Observatories Institute for Astronomy. So let me back up here. This is the VOG Measurement and Prediction Project, right? That's part of Mauna Kea Weather Center. And so you can click on either of these images right here. They actually put in, I'm not sure if these are updated for the current levels of gas coming out. That may not actually be the case, but they do put out some amount of prediction based on the gas coming out of the summit region in general from the summit of Halemaumau at a certain fixed rate. And so you can kind of see here, this is a model based on the current meteorology, the wind pattern of where this volume might actually go. And so let me zoom into it, you guys, here, so you guys can kind of see and let this kind of play where it may actually be foggy today. And that's where the worst of the areas are, right? So on this map, Pahala might be in an area of somewhere over here, Kahuku is somewhere in here, Ocean View somewhere in there, very roughly in those areas. I'm not sure if you guys can see my drawing color there. Here, let me change it here. And so, all right, try again. Pahala is somewhere in an area over here. Kahuku in an area somewhere over here. And Ocean View in an area over here, right? So that explains why we'd see some of these worse concentrations, right? And so we do see some red on the plot over here. So it may actually be that they are actually putting in these higher SO2 values into the model. And we can kind of see where these might come from. We have satellite measurements going on now. We have the GOES 17 satellite providing high-res images, but I want to kind of take a pause here and address some images or some questions. So give me a minute here to figure out some questions. And let's see, one question coming in from YouTube is, how probable is it for these slopes to cave in due to the weight of all this new lava? Thanks to Hugo for the question. Well, the slopes are kind of really rubbly anyways, right? And so it's kind of the angle of repose, like the natural angle they can sit at. Considering a volcano does a lot of shaking, there's a lot of earthquakes, it's always kind of settling all the time anyways. So it's kind of got to where it can be like when you pile sand or dump a bunch of gravel, it'll sit at a natural angle of repose. And so it's kind of sitting at that natural angle of repose coming into the crater, and the lava's running down that flank and just filling in the gap through there. And it's making a pretty solid pad in there, and that's going to kind of push against that cinder, right? And cinder and ash and all the like rock dust and stuff like that. And it may actually be able to put some fingers through it in little areas, but really that's going to be, it's got nowhere to go except into that lake overall. That's the where everything is heading now. So it might inject little areas like to the sides, through little cracks, like through the little pukas, the little holes. I don't expect to see any collapse of the sides. In fact, yeah, more of just filling it all in. So, all right, that was a question we had coming in. So let me find some other questions here. I know I got a whole bunch of comments here. I can get them going. So thank you guys for tuning in. All right, so question coming in from Bonnie: could lava fill up as high as lava vents? Certainly, we just saw that happen with the first one. So maybe they put that first image back on here. Nope, that wasn't. Let's do this. Nope, this one. Pardon me, you guys. Okay, that one right here. So in this animation right here, I'll zoom into it to make it extra clear. And it's kind of blurry once you get kind of that zoomed into it, right? Look at this vent right in here. Right, this one right here. Starts off as one of the first fissures. And the first fissures there is one above here as well, right? The lava level is coming up and it's kind of buried it, so that by the end there, by that last frame, let me get it back on here. By this last frame of the video, you can see what looks like the fountain kind of actually turn into a bubble, right? Like a bubble with lava kind of all around. It looks like lava lake. I'm gonna change my color again here, you guys. Like some kind of flow structure, whether it's ropiness or crust or the movement of the crust. You can kind of see that kind of crust, lava lake crust pattern starting to form, especially over here where it's kind of starting to break apart a little bit, right? But right in here especially, right, things bubbling up with lava surrounding it on all sides. So yes, the answer to the question is yes. Lava could come to the level of vents. These higher ones over here, that's going to take it erupting for a while longer. Now, we've mentioned that eruptions like this in the past, have gone from days to up to a month, following a giant pit collapse. Of course, there are many we don't know about, and we'll kind of point out USGS is leaving a door open for longer eruptions that last decades, within the pit as well. So without knowing anything more about it, if this thing goes on long enough, it could certainly come and bury this vent. And this one can become bubbling one as well. And if that were to happen, then we're going to actually see that thing spill up onto that inner collapse area and eventually onto the caldera floor itself. You know, that could be the end game if it goes on long enough at a high enough rate. That would still put it within the caldera, which is something UHV wants to emphasize, USGS wants to emphasize. It's all within the caldera. There is no lava going towards the ocean, towards anyone's houses, going outside of the park, anywhere dangerous like that. It's all kind of staying within the pit. And even if it gets out of that inner pit, there's another pit. If it gets out of that pit, there's another one beyond that as well. So that's the situation there. Thanks for the question. Let me see what other questions we have going on here. Spillover, yeah, we're just talking about the spillovers, so thank you guys. The lake that was the water lake that was been there for a while is no longer there. So let me pull that sequence back up for you guys. That is this one. All right, let you guys watch that again, right? You can kind of see the beginning of this image here. There is a lake. And at the end, there is not. Okay, so mahalo you guys for tuning in from, see you guys tuning in from Puna, see you guys tuning in from Hawaii Island, from other mainland, all over the world. Mahalo for tuning in, you guys. So yeah, it'll be very interesting to see how cool the Caldera gets. These are definitely images. We'll get to the point where we, you know, as we update here, there could be things being released, and so we'll catch up here in a little while. All right, frame by frame. Lava Lake. I'm just coming over the questions, you guys. If you have any questions, please feel free to drop them in here, and I'm just going to catch up, and I'll catch up again here at the end here. So, so a question from Anthony Quintano. So what happens when the lava reaches the uppermost vent? Does it stop filling in or continue filling up? It'll keep filling in. It'll keep kind of filling in and bubbling up. It'll bubble up. If it actually gets to the lava level above that vent, gets deep enough, we can see a Kīlauea Iki situation, where the lava level can actually pour back into that vent temporarily and block it, but that's going to allow the gas pressure to build. A big bubble is going to form, it's going to burst out, and then actually start fountaining from there. If it does go to that, we might actually see higher fountains of lava, right? Because that's what happened at Kīlauea Iki, was higher fountains of lava as that was able to kind of prime itself and shoot higher and higher. But that all depends on the dynamics, the shape of the actual hole, like the nozzle, so to speak. But most likely it's not going to shut it off. It's probably going to keep bubbling in there into the pond as the most likely thing, right? If you imagine the old lava lake at Halemaumau, we didn't have a surface vent pouring into it from above. It was fed from below, bubbling from below, and that was the same kind of bubbling surface. You'd see that would be what you'd expect again, would be that lava lake image like that. Of course, the surroundings, everything around there is all different since then. All right, you guys, I'm still catching up on the comments and on the questions. Let's see some thank yous. Mahalo, you guys, of course. Pele's hair, yeah. So we see reports of Pele's hair, video of Pele hairs on cars down in Puna. Here's a question: any idea of the volume of lava in the underground chamber it's coming from? Well, the whole chamber is pretty big still, right? Some of the estimates following 2018 suggest that it may have deflated or lost only 10% of its volume to feed that whole 2018 eruption. So there's still quite a lot left in there. Of course, it's kind of just priming the pump, and so kind of primed underneath Halemaumau, and it's coming out through all the rubble, the weakest spot, and that's going to be the weakest spot for a while, it seems. So there is no activity at Pu'o'o. We can kind of get to some of that a little later, but the lava levels the high lava levels is something we'll look for in reports coming up here as well when we look at the USGS, Facebook, and Twitter as well. I'm trying to catch up you guys with some of the best highlights from what's happened since our update about 12 hours ago, and kind of catching up and adding on to what we gave you guys last night as well. How much higher do you think the lava level will reach? It all depends how long it goes on. It could actually come out quite a bit, right? So, I mean, in this image, it's been moving for you guys, and we can zoom it out. Right, so in this image, we have this whole other lower ledge in here, right? Another cliff right through here. So there's kind of this inner pit. There was a smaller one that's kind of below that smallest block that kind of filled first. There's another one, something like that, There's another one. That's that one. There's another one. That's this one. And finally, we have the main Caldera wall way up there. So there's a lot of levels for this thing to fill in before it can actually get up and out of actually what would be threatening to any infrastructure or anything like that. So there's a long, long way to go. That'd be a huge, huge amount, and it probably couldn't even get, you know, we'd have to see a lot of changes. It's going to be quite a story if we get to that point. So we're not jumped the gun on anything like that yet. Just pointing out to you guys how many levels of pits it has to climb up and out of before it can actually get anywhere. So we might see it changing in shape and getting wider and wider, and obviously the higher up it comes, the more likely we can see it from the open viewing areas. That's the question I see. Is it park setup viewing areas? And the trails are open in a national park. There is still COVID pandemic happening, so they are still having all their protocols, social distancing, masks, all that should be practiced. But the trails are open. The visitor centers, I don't believe are open. They have avoided doing that because of crowds of people, and so to protect their staff. So we'll wait to see if there's anything that opens beyond what's open now. But as the level comes up, the areas that are open now may become accessible for us to actually see the level from all around Caldera. That's the ideal thing. We now are looking essentially at a giant lava lake stadium. It's just got to come up high enough for us to see it from anywhere around there. And it may be that that's coming. I have a gut feeling that it's going to go on long enough, at least a couple of weeks, where we're going to see that. So, but we'll just have to wait and see. Has the volume of eruption started slowing down? I'm not sure about that. We'll have to look at the USGS for more information on that as well. I don't believe so. It seems like it's coming out. I mean, okay, so what I can say is there were 3 fissures that began this eruption, right? Let's go back to this image. Right, so 1, with the second one down here as well. 2, the second one down here as well. And 3. This is a big one that's coming up and in, right? So actually, as is typical, as we talked, was possibility on our update 12 hours ago, as fissures develop, as happened at Kīlauea Iki, over time, the smaller parts of the fissure will kind of clog up and close up and stop erupting. And instead, the pressure will divert to the open areas. If you guys remember, a fissure is a crack through the earth. It's like a blade. It's a blade of lava coming up through a crack that has different fingers that can pop up in different places. So when we're looking at this, we're seeing one finger here, another finger over there, another finger over there, right? Different fingers of this blade. 3 fingers, I guess, in this case. But it actually has these lower parts as well as upper parts, kind of these areas 1, 2, and 3. Right? So we have seen number 2 shut off. This is no longer erupting. This one is still erupting, but more weakly. So it's on a down. This lower one over here is still erupting, but it's also more weak. And so it is bubbling through the lake, but that could actually stop bubbling at some point. And so maybe of most concern is, will it reach the height of this event up here, right? And so in a future update, we can recap Kīlauea Iki eruption as we're further into this and kind of want to look back at more of the historical analogs. But as of now, it doesn't seem like it's going to get up that high, at least for a little while. So, okay, let's see. More questions. Viewing area. Okay, volume. Is it possible for fissures to open up like during 2018? That's what we're seeing, but we're seeing it where the ground is the weakest. The ground is the weakest right now at the summit of Kilauea. And so what's different in 2018 is in 2018 we had a much higher caldera. The magma chambers were both full. The south caldera and upper Halemaumau chamber were both full. The lava lake was spilling over, right? It was spilling over, filling the Halemaumau crater floor, that inner pit, right? All except one little piece of hill that was from the 75 eruption that kind of lasted in there. So that allowed pressure to move to not only reach the summit, but translate all the way to Pu'o'o. And Pu'o'o was also inflating and rising up. Its crater floor was rising up. And so when Pu'o'o actually was able to drain its lava into a newly opened crack, that was the beginning of lava reaching down to the Lower East Rift Zone. So what we don't have right now is we don't have any indication of lava anywhere past Mana'ulu as far as this kind of activity, right? In fact, like if we think about it as like a long hose, we have a puncture in a hose somewhere way, way upstream. So you just can't build any pressure downstream if once you already have the puncture upstream, right? And if we didn't even have lava coming out of the ground, think about where the wall, like where that hose is the weakest. Where is it going to break when a pressure actually gets higher? And that's at the summit, and that's what we're seeing here, right? So that's the question of fissures. So fissures, we are seeing fissures, these cracks with lava going through them and a blade with different fingers popping out. In this case, we might call them, 1A, 1B. Maybe 2A, 2B. This is just my own. I'm going to wait till USGS calls it something official. But for now, in that one, 3. Right, so that's kind of the fissures. Fissure 1, 2, 3. All right, more or less something like that. So we'll develop a drain. That seems unlikely. It's likely to kind of keep coming out of the vent until it either reaches some equilibrium and kind of can stop releasing its pressure, all its gas. It's really the gas that drives these eruptions. That's brought up by this very hot, young magma. Could this be a long-lasting eruption? We'll get into this a little bit later, but I just my own gut feeling is that we look at the 1924 eruption, and in that eruption we had 7 different candidates over the next 10 years to choose from. The one that lasted the longest was 33 days. I kind of think that to be like a reasonable kind of upper limit, right? Although there are many gaps in our knowledge. That's only one data point. And there are times after eruptions in the 1800s, right, where we had big collapses, where we know we had lava lakes afterwards for many years on end. And so it could come back and be a lava lake for years on end as well. We don't know that. We'll have to wait and see, how it all plays out at this point, right? So I initially came out saying, I still lean more towards it being a shorter one. But USGS has pointed out, and rightfully so, that there is still a possibility for this to be one of the longer, drawn-out events that we don't really see as well in a record. Right? Okay, so I'll keep scrolling through the comments here and questions. So, can we see a repeat of 2018 where earthquake opens up into the base of the Caldera? That doesn't seem likely because the rift zone is the south flank has already been moving. It's already been mobile. There's nothing kind of allowing it to pressurize down there to allow it to kind of open that pathway again. So that's just how it seems right now. Of course, if this goes on for a long time, we'll really have to wait and see how it actually develops. But so of course, as is the name of the game of the kind of work that we do here, we're giving you guys all the most current USGS information that we can find. Trying to offer you guys some more analysis, interpretation of it, where these things might align between one image to the other. But in the end, we're gonna have to wait for USGS to really lead us on this. So, all right, guys. So, how many feet below? Let's lower rift. So obviously it's a big concern for everybody. There's no signs, there's no earthquakes, there's no tilt, there's no signals like that of anything past the Upper East Rift, right? So that's as far as Mauna Ulu. That's still in a national park. And so if it were to go down to East Rift, it seems likely to happen more likely there than anywhere else first, right? Where we see more activity, and there's been uplift in the last few weeks and all of that. There's been none of those signals happening anywhere farther down, even at Pu'o'o. Right, just to be clear, that's why we're leaning towards this, really not having any way to get to the Lower East Rift unless something else changes, right? I suppose if there was the giant earthquake, but maybe the answer to the question, Anthony, is that that we don't seem to have the same conditions for that earthquake as we did before, right? That earthquake happened in pretty close to the location that happened in 1975 earthquake as well, and you can kind of see it. That was 45 years afterwards. 43 years afterwards, yeah. So it can take quite a while for those earthquakes that could be able to reset to have another big one like that, especially once they're already moving, when the ground is already moving. So, okay, so we'll have to do some comparisons. Thanks, Nathan, for the questions. The deeper, how much deeper is the crater, and is lava lake larger? I believe it is larger, but I will have to go back and look and compare it. Get the guys on the next update as well. So, report from Jennifer in Ocean View. We're back to ugly gray sunsets soaked in with fog, no fresh air to breathe, and I guess they don't be able to see the conjunction tonight. Well, hopefully the winds will change for you guys and clear it out for you guys. And yeah, but we are now in a it's a good example of how the biggest impact to people right now is going to be the air quality, particulates, and SO2. That's actually streaming. So Rob says, don't forget to mention my credentials. Okay, so if you guys are wondering, I'm a geologist. I got a master's degree in geology. I was a volunteer and contractor at the U.S. Geological Survey, Hawaii Volcano Observatory. That's been a long time ago, so I don't have any connection to them now. I'm completely independent now. But I'm basically giving you guys the geological explanation, of someone who's been watching the signals for a couple of decades now, and going through and seeing how things change, and actually, trying to piece it all together and share it with you guys in a way that's more understandable. And I kind of got to that point by being able to give volcano tours within Kilauea, and that kind of allowed me to practice a lot of the analogies and those kind of things that are useful to people to understand how the volcano actually works. So, all right, let's move on here. Magma. Main factor for fissures to open up is wherever the ground is the weakest and cracked already. So wherever the crack already existed, the magma probably pressurized through there. I mean, it seems like let me jump. I'm gonna jump way ahead to this one. This is an image we showed in the last update, the last couple updates actually, because USGS had done a model of the injection of lava that happened underneath Halemaumau on December 2nd, right, over 2 weeks ago now. And so they modeled this being a planar feature that kind of was getting deeper in that direction, right? So maybe if it was coming from a deep source, it was coming from here and actually going over here. And it may be that if that was our actual source, that's why it's put up our vents here, or right in an area around here. It's hard to see with these dots on the map, but right through here. This is a zone of where our fissures actually are, right? So 1, 2, 3, about in there. So some source been feeding our eruption and its injection as well as the most likely thing underneath this eastern part of Halemaumau, which is where we've been seeing most of this inflation and the action in SAR and all the other signals ever since eruption was over. So, all right, let's go back to, where was I? I was actually on a VOG model way back when, yeah. So I see danger of big explosion. We don't believe there's no danger of big explosion anymore. And I'll show you guys why the USGS believes that as well. My reason for saying that, and they are also agreeing in the actions that they're taking. We can see. So to kind of recap, whoever is just joining in late, the reason no big explosions, the lava came in slowly enough at the regular rate, we'll call it, to actually vaporize all the water without exploding it all at once, right? And so I was able to kind of, over a course of 2 hours, boil away all the water. And after that, it after that, it filled with lava, and now we have a lava lake, right? So I see people reporting that Ikaika was live with the news. Yeah, we're gonna go up there and meet with Ikaika. We're gonna do some reports from up there closer to the action later tonight. I just wanted to make sure to cover you guys all these all this media that's come out from USGS and all the gas signals, since gas is our biggest impact today as well, right? So I'm trying to get to the comments, you guys, but you guys are just commenting too fast for me to kind of get through here. But one question, Mauna Loa. We have no concern about Mauna Loa. Mauna Loa is not part of this action at all. It's like Ken Boyer is live as well, so as it's getting dark around here, more live streams from Halemaumau will be coming up. So let me just check over here. Is there any connection with the Great Conjunction? We don't believe so, at least on a measurable scientific level that we have today, right? People are free to believe otherwise, of course, and so, but it's interesting that it is happening at the same time, right? And there's also another volcano erupting in Mexico, I believe, at the same time as well. So maybe show you guys that a little bit about that as well. Thank you guys for tuning in. Yeah, so yeah, I think we've kind of addressed some of the questions here. So I'm going to move on with some of this gas work over here. And yeah, please feel free to address questions. If I don't get to your question on the live, we'll try to follow up with it on it afterwards, right? Okay, so I'm going to show you guys, this is a video from the Gemini Observatory. So this is a webcam at the summit of Mauna Kea, and it's looking to the south, and it's a time lapse. You guys can see in here the eruption, Kilauea, behind the summit of Mauna Kea, in a perspective of this Gemini camera. Let's look at it again. Right, so we're talking about these air impacts. Where's the gas actually going, right? You can kind of see that there is quite a lot of gas coming out. And we have mentioned that there was quite a lot of steam that came out. It was vaporized with the initial blast of lava turning all that water into steam. But there's also a lot of gas coming out, CO2, SO2, water vapor from the actual ground and the magma itself that puts out quite a lot of gas all the time without any need for a pond being there, right? So we'll see how that all plays out. And one thing I wanted to point out to you guys is, as we go along here, we've been following USGS Volcano's Twitter handle, and they are doing a great job putting out information. For example, fresh tires from HVO field teams in the Tephra, right here. They're driving down there to get closer samples. Geologists labeling Tephra samples.
If you've at least started researching Milky Way photography, you most likely have come across the term Milky Way season. Here
we have a retweet by a researcher at Michigan Tech University, Simon Karn, showing the actual impact that the SO2 signature on a satellite right in here. So there is that. And so, for example, we can then go to someone like Simon or Dan Lindsay's Twitter feed and look at some of these.
And where to find them at what time of year. But before we do that, it's useful.
All right, you can see some of these. This is the Go 17 imagery right here. So this is a high-resolution plume of Kilauea right in here. Right, you can kind of see the plume is drifting downwind. It's clearly visible. Satellite imagery all through here. I guess kind of put it up to the right a little more so you guys can see. All right, kind of see some, at least all through there, vapor trail, all the combined gases. This is from this morning, Go 17 satellite, and as we said, this is something that's a lot of activity on Twitter. People using satellites to help track this eruption, including, we mentioned Simon Karn at Michigan Tech. And for example, this one is looking at the signature of sulfur, these kind of yellow puffs. This is showing more of the sulfur itself, not just all gas, but how much of it is actually just sulfur coming out. And so you can kind of see a puff of sulfur coming over there, right from our source right in here. Right? So quite interesting to see that puff of sulfur. All right, so Simon's got more than just this. So let me kind of scroll down and see. Right, here's this other SO2 mass, right? And so I wanted to kind of show his tweet here. Let me make it a little bit smaller. All right, so what it says here is, first look at SO2 emissions generated by that 2020 Kilauea eruption, detected by Sentinel-5P tropomi on December 21st. Coverage is incomplete, but SO2 amounts look similar to those measured in the early stages of the 2018 eruption, when there was a huge amount of gas coming out, right? So we can expect there's quite a lot of gas coming out from there. And so they're saying SO2 mass here, 8.38 kilotons is a number on a Sentinel 5P report. I'm going to zoom into you guys. You guys maybe can see that. Right, SO2 mass. And that was, this is dated by now, of course. Right, so you guys get on Twitter, you can look at USGS volcanoes, they're tweeting out, retweeting, and, you know, sharing that information there. It's a good way to make sure you don't miss anything, right? And I'm kind of integrating everything for you guys here. So we're seeing the gases kind of blowing out. So is it affecting anywhere else other than Big Island? And so if we look at the actual DOH site, there is an air quality site that covers the whole state, and we actually is showing green everywhere, even Pahala and Ocean View right now, but certainly no effects on any of the other islands from the gas that we can see right now. Okay, so let's move on from that. And I'll show you guys, this is the FIRMS, the Fire Information for Resource Management System, NASA heat map. And so this is looking at the heat. And you can see it's detecting heat all through here, right? So some of these are probably the plume is the little pixels where it detects heat, but clearly the center of the action, if we had completely socked in weather and no one was allowed to go outside, we could see that there is, you know, a lot of heat. And this is something that is used more so on less populated areas where it's harder to see. Right, so okay, there's our heat map as well. All right, so gas and ash is flying in the air. What about aircraft, right? So FAA issued a restriction on flying, right? So there's not a restriction, a 5-mile restriction around Halemaumau that goes all the way up to 34,000 feet. And this was issued in response to the aviation code by USGS HVO being put at red because of the danger of explosive eruptions still being involved, and that could put ash into the higher parts of the atmosphere, threatening aircraft. So for that reason, the USGS HVO put out that aviation warning, and FAA followed up shortly afterwards this morning at around 10 a.m., putting that 5-mile flight restriction around Kīlauea in place. Right, so that's the area of restriction around Halemaumau, right there in the middle. It's a restricted area all around, right? All right, so let's look at what the USGS actually has. And so if we look now on the USGS main landing page, right, you can see they've updated their cover image over here. Fantastic. Latest information. You guys can click here to get the latest information. That opens up photochronology, webcams, all that kind of stuff. If you scroll down, you can see that Kilauea has now been downgraded from red to orange. We're now at orange watch on Kilauea. We started off at red. We're at red for probably 12 hours until something like 10 this morning. We got downgraded to watch. Right, and I'll show you guys the release from that and kind of scroll down here, but kind of correspondingly, Kīlauea now has this orange triangle with an eyeball in it rather than the red one with exclamation point that we saw for the eruption earlier in our last broadcast. Right, so let's scroll down here, and you can see that they have on their page news feeds. If you guys want to look through all the different news feeds, this one is Kīlauea Volcano Erupts. This is the one that has been updated. And so you guys can see on here an animation that I showed you guys earlier, right? The kind of animated GIF of the fountain last night from that fissure, that third fissure. And more information about the glow, awareness, about the background, kind of summarizing everything I've told you guys here. There are more images, more pictures over there as well. Okay, so photo and video chronology. That's what I started off showing you guys right here. Right, this is one of the newer photographs, but we actually can go back to the photo and chronology page, and you can see they have a whole series of different views. Morning plume. This is probably an ideal time when I have all that sun back in there. You can see that, look at the sun through the plume to do some gas measurements, so we'll probably hear about that at some point. I would expect in the next day or two. Here we can see HVO geologist, research geologist Carolyn Parchetta, looking down next to these webcams and thermal cameras at this eruption. There is a lava lake down there. There is a fissure. There's fissures over here as well, kind of cascading down and in. right? She's looking using some kind of optical instrument to perhaps measure color or measure temperature or something like that. There's all kinds of data being tracked all the time by these researchers. And you guys can see some of the images that were posted earlier on there. All right, so I want to make sure that we cover this one that was put out at 10:15 this morning. It's showing a UTC time of 2014. That's 10 hours after us here in Hawaii. And so this is actually notice for aviation. So now they've actually also downgraded from red to orange the aviation, right? And so I will read you what they say here. Let me scroll down to the relevant section. All right. Kilauea volcano is erupting. At 9:30 p.m. Hawaiian Standard Time on December 20th, the USGS Hawaiian Volcano Observatory detected glow within Halema'uma'u crater at the summit of Kilauea volcano, indicating that an eruption had commenced within Kilauea summit caldera. Due to the presence of the water lake at the summit of Kilauea and a potential for steam-driven explosions and related hazards, HVO elevated Kilauea's volcano alert to warning and its aviation color code to red on December 20th as the progression of events was uncertain. The water lake at the summit of Kilauea has boiled away, and an effusive eruption has commenced, with 3 vents in the wall of Halema'uma'u crater generating lava flows that are contributing to a growing lava lake at the base of Halema'uma'u crater. Eruption is currently confined to Halema'uma'u crater. HVO has decreased Kilauea's volcano alert level to watch and its aviation code to orange, reflecting the less hazardous nature of the ongoing eruption. And then more links on there. So that's what I wanted to share with you guys, right? That's so even though we have now downgraded back to an orange, we still have this FAA in place, restriction in place, and this is last I saw in effect until the end of the year, December 31st. Right, so we'll see how that progresses. If they also lift that restriction now that the HVO has downgraded their levels as well. Okay, and so you can click on more news on that page. This is all HVO News is putting out, so you can see that there's the eruption release there. Photos from today, release from earlier, photos from last night, earthquake about a statement about the earthquake last night at 4.4 in the south flank, which hasn't really had any kind of consequence. So that was kind of just an adjustment of the south flank. Still, that seems like the most reasonable way to explain that. And initial notice over here as well, going back to their volcano watch from last week, talking about the intrusion, and then going back. 404 Mauna Kea, awareness. You can kind of see going all the way back to where there's lava. So all kinds of information on the HVO website. You guys can go use it. It's certainly a huge resource. And as well, we make sure to reload and see USGS volcanoes on Facebook as well. So they're also doing a great job of putting their images on Facebook. You can see the similar images we saw on Twitter. Right? Video I showed you guys earlier was on here. So if you guys want to find any of this imagery, it's all, this is how you look for it right through here. All right? Helicopter imagery. So looks like we're fairly caught up as far as I can tell on this. So let's look at the earthquakes and see how our earthquakes are progressing. So it looks like our newest earthquake was this one, and it was at 3 o'clock. So 3 hours ago, 0.9, 1:45, 0.8. So the earthquake phase is basically, seems like it's passed on here, right? But what I want to show you guys as well is, let me switch to the seismographs here. So 48-hour seismographs on Kilauea. This is just a compilation I put together on my own site. So you guys can see that right around 9:30, all harmonic tremor begins. All these dark blue lines showing the ground vibrating, right? As the fluid escapes from that crack and creates a harmonic vibration. It's like blowing through a flute. In that case, like the fluid air vibrates against the wall of the flute, right? In this case, we don't hear it. This seismograph can detect it as what we call this harmonic tremor, this kind of much heavier ink you see going through here. If you guys haven't seen seismographs before, this is now a 48-hour plot going through here. So 1 day, 2 days. Each of these lines is 15 minutes. And so you kind of go down 15 minutes across. starting again at the next line and going over and over and over and over again like that. So I can kind of scan this and at a glance tell you that since 9:30 last night, right, there was quite a lot of tremor earlier on. The tremor seems to be lightening up a little bit based on this, right? Tremor was especially heavy for the first, looks like 4 hours, 6 hours eruption or so, right? And so if you scroll down to the rest of the Kilauea seismographs, you can see a similar pattern. These are summit stations. The Kahuna station looks like it's a little bit wacky. It's not quite giving us good data, but you can see that many of the other ones are consistent in showing us all this data. Hill, Outlet Digital, Rim, same pattern. I think Akoi is a little funky as well. Byron's Ledge, clearly showing it. A lot of these earthquakes that kind of were leading up to the event, visible here as well. And if I zoom in on this, maybe. Right, all through there, those little earthquakes. Let's keep going through here. If we look at the East Rift, you can see some earthquakes, but those are the earthquakes on the East Rift right through there, right? You see some kind of little bit of tremor, but nowhere near the same kind of signal as we saw elsewhere, right? Kind of near Yohamo, the tremor is detected from far away, but the earthquakes are much stronger. And clearly the lava is far away, it's not anywhere in here, right? Pu'o'o, also, no harmonic tremor. Pu'o'o, there's no fluid moving anywhere near there. All right, keep going down to East Rift Zone, Pu'o'o, Pu'o'o. There's a little bit of something happening here, but you know there are other factors as well, such as wind and traffic possibly as well. So we always be careful of the location of these instruments and other noise contributions to the data set here. Clear earthquake visible here. Kupai Naha Station, that was that 4.4 that everyone felt last night. And not a whole lot of, a little bit of tremor through here, but really not a whole lot. Jonica Station certainly saw the earthquake and, not really any tremor. Maybe, some of these other long period events kind of, some other kind of adjustments nearby, right? But I'm not sure where these are coming from as well, right? There's a lot of stuff being picked up from far away. So there is no evidence of anything here anywhere being near the lower East Rift Zone. This is a Highway 130 station, kind station, and you guys can see, like, for example, when you're by the road, you might see something like that, yeah? So it doesn't really correspond to the same time as we're looking at. And perhaps it does. Perhaps it does show some. It's hard to say, but it could actually be. This is something where if there's more traffic on the road, you could also see that on a seismograph as well. Pihikau. Okay, south flank. On a south flank, up close to the Caldera, we do see the signal, right? Here it is, coming in at 2045, right? So clearly that other signal we just saw by 1:30 was like something at 9:30 in the morning, some car driving by, something like that, truck. South flank stations, same kind of earthquakes, tremor, but that's basically the pattern right there, right? So while we're over here, let's give these webcams a refresh. Show you guys what these webcams are looking like. Maybe we'll do that back over. Let's do this. Let's reload this one, and this might actually show us all those different time lapses that are being put up on the HVO website. Possibly we can kind of see them one after the other here. I'm just kind of moving through some of these time lapses, kind of recap what the view looks like. Now we're at Mauna Ulu, Pu'o'o. There's nothing to see in any of these. There's no red glow, nothing anywhere down here. Right? It's really only the summit stations, right? So the HVO summit webcams, right? Hanamama West Block, Eastwide. Starting to see some glow as it's getting darker up there at the summit right now. Some glow right there. Our latest thermal image, let's click on that and check that out. And you can kind of see still bubbling on that lower pond, that lower area through the lake, right? And this crust still seems to be moving over this way. So okay, so that's that's kind of the story of the earthquakes there, and kind of recapping how that falls into all the earthquakes. Earthquakes happened December 2nd, a whole bunch of them, and of course have been elevated earthquakes for a while, although maybe not quite to that level. So just finish it off here. Here's our tilt. Let's refresh the tilt. And so in our 2-day plot, we can see there's just a big drop from 5 to minus 15, 20 microradian drop. 1-day plot, see a little bump recently. You don't really see much of the bumps up here. So most interesting one to look at is this past month plot right here. Look at the past month tilt on the HVO website. You can kind of see December 2nd event happened right here. This was a lava injection, right? It kind of tipped the ground in one direction. It's kind of been at that level. And then now the pressure is being released and it's coming back down. Okay, I'm going to change my color of my pen again for you guys here. December 2nd, then kind of somewhat stable and then back down. Although you could argue there's been kind of a increasing trend right through here, right? Something like that. Maybe that's a little better way to draw it. Right? Going up and down, right? So that's what the tilt's showing us. GPS, it's still too soon to really see anything on a GPS signals through here. That's something we see kind of, you know, on a longer time scale than hours and days, right? So, okay, I want to make sure I point out I showed you guys some of these images yesterday or maybe this morning. Hawaii National Park. This is 1927. You can see in this image 1927 right here. A fissure on a wall of the crater, right? Here's the upper part of Hale Maumau, so deep in the pit on a crater wall. It's got a kind of like lava flow coming down. It's feeding a lava lake down here. It's kind of off camera. Photo by Tai Sing Lu, 1927, right? So the guy who also took this famous photograph of 1924 explosion at Kīlauea. Right? So we also have pictures from 1934, and if you guys are all at the summit now, and looking at some of the imagery, the image right above me, just to remind you guys, this is National Park Service, Janus Way, Hawaii Volcanoes National Park Facebook. Very similar images, 1934, right? This is in black and white, obviously, right over here, but this is a very similar view. Seeing the edge of the crater over here, the deep pit, and all the steam and gas coming out, right? Very similar view in 1934 to today. And so in 32, compared to what we saw in 27, here's a vent with a lava lake up near the level of the vent, right? So the lava's kind of at the same level almost. It could start drowning in and out and affecting the vent and possibly drown it out over here as well. So that's a viewing unit 1934 as well, right? So I want to point that out to you guys. And also this cross-section, I don't think I can get any bigger than that. But this is kind of just showing in the collapse pit of 1924 at Hale Maumau right in here. The flow 1924, 1927, 1928, 1929 twice, 1930, 1931, 1931 and 32, 1934. And in the end, it filled in all this chunk of that collapse area with a new pad of lava at the bottom of the pit. And that's what we see happening now. It seems like it's happening possibly a lot faster. We'll have to wait and see how its eruption progresses, but and look at some of the volumes. I haven't seen any volume reports for you guys that are asking about that from USGS Facebook or Twitter, and so we'll look for that as well, and we will report when it is announced as well too. But if the gas measurements are any indication, the flux is pretty high as well, right? We had from the, let me go back to this image, right? This is an image that came from the Volcano Watch this past week, and we know that from the previous week's Volcano Watch, it was about 4 hours of inflation injection that caused the uplift of the ground. But we have this Volcano Watch from last week that talks about that event on December 2nd, and they say, preliminary models suggest December 2nd intrusion was small, contained anywhere from 10 to 30 times less magma than the intrusion of May in 2015. Its volume was equivalent to the volume of lava erupted in just 1 to 2 hours from Fissure 8 during the 2018 eruption. However, even though it's small, it's still potential for future behavior. So what they're saying is 1 to 2 hours of Fissure 8 was the same as 4 hours of the injection on December 2nd. So this could be moving, it could be putting out lava, maybe not quite Fissure 8 volumes, maybe half that amount. if that intrusion is any indication. Of course, now we have an open vent, and so it's a whole different dynamics. It's coming out a lot faster if the gas can escape and drive everything out as it keeps kind of bubbling and degassing. And now all the gas that's been bubbling within the magma chambers for the last 2 years can all work its way out, all that frothy stuff. All right, so I want to point that out. And I also want to point out that there are updates going up on hawaiitracker.com website, including things like this post right here, which is how to view lava safely within a national park by Hawaii Volcanoes National Park. And so they're saying that the eruptions are hazardous, stay on marked trails, avoid earth cracks and cliffs, do not enter closed areas. Gases are a danger for those who have heart and respiratory problems, infants, children, pregnant women, and everyone. Slow down, drive safely, long waits for parking spaces, maintain social distance and wear a mask. It's chilly, bring rain jacket and pants, and so you can kind of see updates like this on Hawaii Tracker's page as well, right? So it's another place you guys can kind of see where we're trying to curate, right, and kind of bring a lot of these different sources together. And this video is just one way to kind of look at the format of it, right? So on a Hawaii Tracker page here, which does take donations, I will say, to support the work that we're doing. Goes West imagery put out by our team members earlier today. Doing safely. Videos. Text updates. COVID updates, going back a little further in time. More of the Goes imagery. All right, so you guys can see that's a Hawaii Tracker page. And of course, Hawaii Tracker is also a Facebook group. And so on a Hawaii Tracker Facebook group, let's see if I create a loop here. You guys can see all of this imagery by citizens, people who are going to the park and seeing the eruptions in the park and commenting and sharing their experiences. This is a great place to see that as well. Here's our live view right there. Let's share that. Give that a share. And you guys can see all different kind of imagery. Another great place to check for more information there is that Hawaii Tracker Facebook page. So what I will do now is I will take some more questions, and then I will make my way up to the park, and let's pull up the most current thermal camera image. Right in there. All right. So, all right, guys, I'll start taking some questions again, and please bear with me as I try to find all you guys' questions, and I see a lot of them. So, all right. So a question, I do not work for the USGS. I'm an independent geologist. I have a master's degree in geology from the University of Michigan. And I've been on Hawaii covering volcano news for a while, especially ramping up in 2018 during eruption in Lower Puna. So I did at one point in time early in my career work at the USGS. That's the basis for a lot of what I know. I still try to stay very connected. Although I am also separate and independent from anything I say. I don't speak for the USGS in any way whatsoever, just to make sure that's clear. I'm kind of synthesizing all our information for you guys and trying to make it understandable and coherent, and more enjoyable. This is an eruption that, unlike 2018, is something we can enjoy the beauty of without worrying about the destruction so much, especially now that we're past the phase of possible explosions, right? Where there's the USGS's downgraded aviation code, downgraded the volcano watch level warning to watch, right? So that's the evidence that they've given for this being a less hazardous event. And so we'll see if FAA follows, but kind of overall, that is the prognosis right here. So Mauna Loa is something that is still inflating. So Mauna Loa and Kilauea often kind of play on each other. So we'll have to see how Mauna Loa responds. As of right now, there's nothing happening on Mauna Loa. Volcano Town may be affected by some of the gas that comes out. We are seeing that, it's a question from YouTube, from Tiny, Volcano Town may be affected. More so in Pahala, Ocean View, there's more gas flying that direction, particulates flying that direction as well. So here's the VOG model for you guys, kind of showing the areas, probably showing the VOG and gas, that kind of thing. All right, so thank you guys for tuning in. Let's see, I don't see any other questions. On YouTube. All right. So you guys are having fun on the YouTube chat. I'm just gonna let you guys go do all of that. Yeah, someone suggested going to Windy. That's something we could do. So let's go in here and let's open a new spot to Windy. I'll show you guys Windy. Zoom into the big island here. Maybe a little too close. And so we can go to the layers. And we can go down to SO2 layer. All right. So thank you for, I'm gonna give a shout out to who gave me this tip off here. We do look at Windy quite a bit as well, but part-time on YouTube. Thank you for the thanks for the tip here. So this is our windy.com feed here showing SO2 Kilauea. You can see it's not going to start having an effect. It's starting to get caught in trade winds here, right? So this may affect other parts of the Pacific Ocean as well, which is no surprise when we start having these big, massive clouds of SO2. Something that came out of 2018 as well, but we haven't really had a chance to follow up on that. More information and research on that coming out soon. But here, massive effect of the SO2 plume. Right, all right. So, all right. So, question from Terry. If you look at where the large event is located, it's very close to where the lakes seem to flow over from 2018. Could it be the same vent just reopening? Or just say it's new? Well, it may be using many of the same pathways. You know, the thing is that the whole throat is clogged with rubble, and it's cracked on the edges furthermore. So it could come up through that old crack in the rubble. Come up with the cracks on the outside. It's coming up through it somewhere in that mess that's all in there. So it could be like the same vent, but really it's been transformed, and you could call it the same vent, or you can call it a different vent, but it's basically in the same place. You are right pointing that out. So thank you for that. So thank you guys if you guys are joining us. Please like or subscribe our video. So Hawaiian lavas, for the guys are asking about. You guys have more general audience out there. People who don't know much about Hawaiian volcanoes. Hawaiian volcanoes have lava that's more fluid. It's more fluid than lavas from places like Mount St. Helens or Pinatubo. It's got less silica dioxide in it, which makes the lava kind of, you know, it's more runny essentially, right? It's a difference between like water, and flowing honey. The water has got a lower viscosity. It can go faster and behave in ways that look more fluid to us. Right? Whereas places like St. Helens, the lava is so sticky that the gases can't escape from it very easy. So they build up much bigger pressure to eventually blast the whole thing up and out. Right? Our explosions of Kilauea are often not from the magma viscosity holding gas in, but rather from water interacting with the magma, which is why we were concerned with the onset of eruption in 2020, that there would be an explosion because of the pond of water that had grown there in this new pit in the previous 2 years since Halemaumau collapsed. However, the lava came in at the regular rate, and by that I mean to point out that every eruption in Hawaii comes up through the water table, and it comes up through water and it causes steaming ahead of the eruption, and it can cause localized steam explosions. That's certainly true. But the big explosions, like 1924 style, like we saw on this image of Tai Sing Lu, like this one right here, right? That kind of thing like we saw in May 2018, like big ash clouds going 30,000 feet into the atmosphere, right? Which would be reason for aviation concern, right? Those are the kind of things that we did not see happening, right? And we've often, going back to our updates over the whole last year, the last 2 years, relying on experts of USGS volcanologists, guys like Don Swanson, talk about how the ascent rate, how fast magma comes up, is hugely important. If it comes up really, really fast, it can get into all that water and boil it all to vapor all at the same time, and then you can get a big boom and a lot of this pulverized rock and ash flying, billowing through the air, and other consequences of fractured rock and things like that, flying rocks, right? That's kind of, that's one way to do it. But more typically, the lava comes up through the water table, steams it away, and as we saw in this earlier video, let me pull this one up again. This is a video of the first thermal time-lapse released by the USGS with a frame every 2 minutes. We do see within about 2 hours of thick steam within this image, right? This is a lake of water. There's all the steam, thick steam. By about 2 hours into the eruption, no more water, no more steam, right? So that's about the timeline that we know for sure it had to have gone. So, all right, let me get to some more questions if I can, if you guys do not overwhelm me. So let's see what I can catch up with you guys. What happened? So what we're expecting for it to happen, kind of see all this is all the lava to kind of fill in, reach the vent, form a lava lake. It's gonna be bubbling up through there, and we'll see how much it actually rises up and through. We don't expect any more big explosions, although the USGS is being very careful to keep that possibility on the table. Keeping the possibility on the table that the eruption could be long-lasting as well. So we'll just have to see how the signals actually progress and how things go from here, right? So, I got a question here from Nancy. Did shelf disappear? Let's look at the most recent sequence here. Let's reload it, and we'll end with that. We'll look at this last image, last 24 hours, and look at our shelf down here, right? You guys see the shelf right through here. Oh, I need to change my color again. You guys see the shelf right through here, this old piece of crater floor, and the lava coming up and onto it. So it looks like the very last frame, it's not quite to the very, very edge, but it's kind of going uphill also. That thing is tilted. It's not a flat piece of crater. So it is coming up and over onto there as well. And if I can go back up here, see the static image, and this is what's really interesting to me. We now have one of these lower vents is actually submerged underneath the lake surface, and it's spattering and bubbling, and clearly forming convecting, right? Convecting plates, crusts forming on this lake surface. You can see it's clearly plunging in here. I see the big plunge pulse thermal signature of this thing, and then kind of cooler pieces of crust on the outside, right? So the lava is probably going underneath this crust right here, going around here, probably underneath the crust over here. It's pushing these things this direction and pushing this lava flow around this way, and this thing's circulating like this as it's filling up. All right, so thank you guys for tuning in. I've been going for a while now, so we will be live again later tonight with more information for you guys. So mahalo, e aloha.